We can also find the length of a list, which comes in really handy for a lot of things as well. The length of a list is basically just the number of elements that it contains, and we use the len function to do that. But again, it's len is a core inbuilt function, so there's no dot notation here. So again, that might confuse you. Whereas with the append, we had to do that as a method of the list object. Len is not. So therefore, we just say len open brackets and then give the name of the thing we want to find the length of. And len will find the length of any iterable object, and a list is an example of an iterable object. So if we put in len my list, we've got 5 elements in our list, so it'll give us back the value 5. As well as adding items to a list, we can also remove items from a list as well. The remove method is a method of the list object, so we do see that dot notation again. So we give the name of our list, and then we call dot remove, and we then specify the element that we want to remove using the value. So it's the actual value of the item we want to remove if we use the dot remove method. So in this case, if I put that line of code there, that will remove hello from my list. Sometimes though, you want to remove it not based on the value, but based on its index. And to do that, you use the .pop method, so the pop method of a list object. And pop works in the same way. It's just you give the index. So pop and then providing a value of 0 will remove the first element from the list. With pop as well, if you just call the pop method and you don't specify any index, it'll just remove the last element from the list. And that's actually really useful. You'll probably use that quite a lot. If you just need to remove the last thing that was added, you just call .pop, and that pops it off the end. Love the name of pop. It's a great name for the method. Yeah, okay. So we can also do something known as checking existence, which basically checks to see whether something is in a list or not. And that again can be really useful to see whether something's already there. And usually that's then followed up by, if it's not already there, add it. And we can do that using the in keyword. So here we've got a simple piece of conditional logic, much as you've seen before, using an if statement. But rather than some of the comparison operators we looked at earlier, we're doing an existence check. So we say here, if to, so the value I'm looking for, in, and then the name of my list. So if to in my list says, if the value 2 is in my list, then do this. So it'll only resolve to true if 2 is in there. If 2 is not in there, this line of code won't run. So it's don't fall into the habits. I've seen people, and quite understandably, type the word is before in, because that's what you're thinking in your head. There's no is, it is just in. You get used to it after a while. So if 2 in my list, then print already there. And you can also check the opposite. You can check to see if something is not in the list. And to do that, we just do exactly the same, but we add the word not in front of in. So if 2 not in my list, then that will resolve to true if 2 isn't there. Okay, so you can do it either way around. Now, if we want to copy a list, you might be tempted to do something like this. So imagine we've got my list equals, and then we set up our list here, and then I say, oh, well, I want to take a copy of it because I want to do work with these 2 lists. If I write this line of code here, copy of my list, I'll use my assignment operator, I'll give it the value of the list. That seems in line with everything I've talked about so far. The assignment operator says, let the value here become be sort of put into this. So the value, this is my value here, put it into that list. That should work, but it won't. Does anybody know what will happen?
Pass the pointer.
Indeed it will. So what it's actually doing is not creating a nice copy of the list. What it's doing is it passes what's known as the pointer to the list. That is effectively the bit in memory that tells Python where to look for this variable. And that's how this will work. So what you'll end up with is just another reference to the same list. So you've just got now two names that you can call the list, but any changes you make using either of those names to that list, you're changing the same list. There is still only one list, just two different references to it. Now, that's probably, in 99% of cases, not what you want to do. I would argue that I've seen very few examples where that's particularly useful, certainly for this kind of thing you'll be doing. What you're usually trying to do is to create a second copy of the list that you can work with separately. To say, okay, I want to take a copy of this list and I want to work with it over here. You see examples of it in machine learning where you'll take a copy, well, we usually do it through NumPy and stuff, but the principle's the same. You take a copy of something so that you can leave the raw data there, but now we're going to manipulate this in a certain way, and now I'll take a copy of that and I'll remove all the references to these patients because I just want to look at this. That you'll use much more. And so if you're doing that with a list, instead we have to use the copy method of a list object. So if this is our list, my list, if we want to set a genuine copy of that list that is a separate list in itself, then again we use the copy method of a list object. So we say the name of the list dot copy. We don't need to pass in any input. That would just create a copy of the list. So now we've got two lists, one called my list and one called copy of my list. Okay. Bad. I mean, don't call them that. This is for teaching purposes. That's a very bad name to call something. You should indicate why it's what you're going to do with it, what use it's going to have. But naming things will get clearer as you start to code more. You're always trying to kind of explain what it is in clear and concise terms.